let's talk about some positives here, okay? What about some possibilities? Quantum computing in AI. Where are these life-saving, wonderful, human applications you see? Let's do some positive,
Well, young girls always ask me, can quantum computing with artificial intelligence find me the right partner for my life? It's very nice. I mean, okay, it's a legitimate question. It's probably for Instagram or TikTok or whatever. So I usually don't know how to answer on that, except that I think we already have everything we need built in within us. And I know a lot of young women who can immediately see the young men and say, oh, this guy is for me, so to speak. So whether artificial intelligence will improve that, I don't know. But I agree with you that artificial intelligence may improve certain things in the healthcare. Also in the big data, as you said. I think that is quite clear. Quantum computing will not hurt in that area, to the best of my knowledge. It will be just faster. Quantum computer will be also more invasive to the privacy, but that is also as you discussed, so I will not comment on that. Maybe you have some better examples.
I would echo that and say drug discovery is a big area of potential for quantum computing, because you have more, according to the researchers in the space, you can create more potential molecular compounds than there are atoms out there, apparently. So it's a very huge number, depending on who you believe. And most of that search space is unknown to us, is completely unknown. So the speed of quantum computing, as Davor pointed out, is so exponentially faster that you'll be able to go through that search space much more effectively, much more quickly. So complex diseases like cancer and other complex ailments that currently often not treatable or the treatments are not that effective, we could actually start finding much better solutions there, and indeed personalized medicine, where we can find the compounds and link to our DNA structures to get personalized medicine, where the side effects of the medicine are mitigated, but the upside benefits of the medicine are massively improved. So absolutely, there are huge benefits in drug discovery, personalized medicine, in terms of other areas of chemistry with new novel compounds. We could discover that alternatives to plastics, etc., enzymes that could go and eat the plastics in the ocean. Huge potential there. So absolutely, and indeed new super materials that we're going to need for more advanced computing, but beyond graphene perhaps. So huge potential there. But again, these are things that are going to come in the future, because the differences between the research lab and real world production. In the lab, I think we find researchers find really exciting potential and breakthroughs, but then getting that implemented in the real world, there's a time lag, and then scaling it. So personally, I don't view that we would get commercial quantum computing until the 2030s. I know Google say they'll try and get it out by 2029. I know a company in China a few years ago said they'd do it by 2020 to personal computers, but they didn't. So we're still some time away. And also, when you take a step back and you look at the challenges we still have to solve to get to AGI, let alone super intelligence, a lot of things are going to have to happen. We're going to have to give causal reasoning capabilities to the current AI, machine learning and deep learning techniques, so they can understand causal inference, so they can understand common sense, which they don't. Even the most powerful deep neural networks, GPT-3 or Google Switch model, etc., they don't get common sense. That is obvious to us as humans. That's how you can still catch them out. That's why they still won't pass the Turing test.